Hello everyone, welcome to Legacy IAS. Today we will be discussing Science and Tech portion of GS3 paper that was conducted just a day ago. This is UPSC 2025 GS3 paper Science and Technology portion. So first of all, the overall analysis of Science and Tech. So this time thankfully the questions were on expected lines, except for one question, and even this question can be done. Other questions were on expected line. They were in most of the test series also of different institutes, and every place we also taught it, everybody taught it. Okay, so questions were good. Sometimes in Science and Tech what they usually do is they give very vague questions, and then the whole point of studying Science and Tech and everything just diminishes. But from last 2-3 years we are seeing that the questions are proper. That means a student who has done their work properly with respect to Science and Tech will be able to solve them and gain good marks out of them. So this is what is there. It's an expected line. There were 4 questions, 2 were of 10 marks and 2 questions were of 15 marks. So in total 15 and 10, that means a sum total of 50 marks out of 250 in GS3 came from Science and Technology. This is the overall analysis that we have. After this we will start with the first, second, third, fourth question. We will deal with the question entirely, the entire question as well as what you should have written and what the model answer should be. Both we will be telling you. Okay, so let's get started now. Let's read this question. Okay, let's read this question. It says the fusion energy program in India has steadily evolved over the past few decades. First part of the question is this, that the fusion energy program in India has steadily evolved over the last few decades. Fusion energy, you understand, one is nuclear fission and fusion. Fission is what? Breaking up of a large atom into smaller atoms, releasing energy. Fusion is mixing or fusing together of 2 or more smaller atoms to form a bigger atom that also releases energy. Now, so this fusion based energy programs in India, they have progressed a bit in past few decades. So that we will see, that you have to mention in the first part of your answer. Students, what they do, sometimes they just forget the initial statement that is written. This straight away start answering the question. That you should not do. So we will handle this. After this, mention India's contribution to the international fusion. Mention India's contribution to international fusion energy project, that is International Thermonuclear Experimental Reactor. This you might have heard, ITER. What is India's contribution in it? Okay, it consists of many countries. Then you need to tell the India's contribution specifically. After that, what will be the implication of the success of this project for the future of global energy? That means if ITER succeeds, what will be the implications? So major part of the question is, first thing, if I were to write a model answer, I will introduce it with the most important part, that is ITER. So what is ITER? ITER so this ITER is actually an international collaboration of 35 countries. Collaboration for what? To demonstrate nuclear fusion as a clean and reliable source of energy. So this becomes your introduction. Okay, that ITER is a 35 nation flagship experiment to demonstrate clean and reliable power from nuclear fusion. Understood? Same thing you have to expand. Now, once you introduce this, now what you should do is handle this part, which is you need to tell India's steady evolvement with respect to nuclear fusion. So let's draw India's nuclear fusion timeline. India's nuclear fusion timeline. Now see, first thing that happened was in 1986, where this institution of Indian plasma research was established in Gandhinagar. This was the first thing. Now this was an institution specifically for nuclear fusion and all those kind of nuclear related work. So this is 1986, IPR was established in Gandhinagar. After this, in 1989, India commissioned its first tokamak or nuclear fusion project. Its name was Aditya. Okay, so in 1989 you see India's first tokamak being commissioned. After this, in 2005, what India did? 2005 ITER, India became 7th founding member. So India became 7th founding member of ITER. In this year, ITER was proposed, okay, and it started its work. ITER is international collaboration work to prove that nuclear fusion, or to demonstrate that nuclear fusion can be a clean and reliable source of power in the future. Now, after this, from 2006 to now, what India is doing? India is a key contributor and supplier to ITER. This is what India is doing now. That is, India is a key contributor to ITER. This is India's nuclear fusion timeline. This you should have drawn in your answer. Of course, if you don't remember some of it, like most people, they knew about this. This plasma research institution was established, that they knew. After this, just add this. This also people know. You learn it in your prelims preparation, that in 2005 we joined ITER. Then after that, 2006 to 6 to now, that you can write it. It's generic that India has done this. This part, even if you miss, it's fine. But if you draw this timeline, it is much better. This shows that you have also dealt with first part of the question, that is showing India's nuclear fusion timeline. Understood? You have to show evolvement. So that you have seen. Now, after this, once you are done with this, then next thing is what? Next thing it is asked, what is India's contribution to international fusion energy projects? Now the next thing that you should present is India's contribution to ITER. This is your next part, that is India's contribution to ITER. Now, what are India's contributions? First is, as we saw that India is one of the founding member along with 6 other countries. Now see, in this part where we have to write India's contribution to ITER, now most people won't know exact what we are providing, which company is providing, because we don't read this in a lot of detail, like what exact things we are supplying. So instead of focusing on your answer specifically on, or just randomly writing anything that some people choose to do, that they'll just complete guesswork. Okay, instead of doing that, what you can do in contribution, you can make points like this, that India was one of the founding members. Then you can always put a point that Indian researchers are contributing, or India is providing manpower, correct. Then there may be, then if anything manufacturing or anything related like that is there, then India would be supplier of equipments. So these generic points also you can add, and some, if you know, because of your prelims preparation, if you know some specific ones that India is contributing in this, some you would know, so that you put in the middle. Understood? Now, second is India contributes over 9% of inputs, or not, of high-tech components. This is second. India contributes over 9% of high-tech components. Then you write down major components supplied. Now some you might remember. For example, people have read about this cryostat. These are vacuum chambers. L&T has designed them, that we are providing. Then other thing that people had read was India is also providing cooling systems. Then diagnostic systems, then radio frequency power supplies. Okay, all these things, even if you remember one or two of them, you can still manage. This is diagnostic systems, in-wall diagnostic systems, in-wall cooling systems. All this India is trying to provide. Even if you remember two, it's fine. Now if you are reading it for 2026, then you should learn 3-4 of them. Okay, even though there is less chances of asking them again in mains, but still you should know. They may ask it in prelims now, so just prepare the PYQs. Now next, once you write these major components that India supplies, next thing you can write about human resource and all that. So you can write that we provide tech expertise, correct, from IPR, one institution you already know. You can also put IIT, IISc, all these you can put. So these will provide technical expertise or researchers. Then last is industry linkage. For example, L&T is providing that vacuum chamber, correct. So many industries have become suppliers for this project. Okay, these are the major things that India is doing. Now the next part of the question is what are the implications for global energy. Now what will be the implications for global energy? See, one is this will demonstrate, or this is proof of work, correct. This will be a proof of work that nuclear energy can be a reliant source in the future. Then second is, this is much safer than nuclear fission. Correct? Why? Because there won't be that uncontrolled chain reaction and all those issues in this. Also, the nuclear waste that is generated in nuclear fusion is last much less time. Then we have something called technology spillovers. Correct? Now, if you see that once we develop cryogenic things or different kind of material synthesis that we do, now these technologies we will deploy in other research and other manufacturing of other things also. So, always something like this which is very technological advanced will have technological spillovers. Then, for example, in power electronics or different kind of things. Then another advantage is this is a form of clean energy. There is no greenhouse gas emissions. Correct? So, this will also help us control climate change. Understood? So, these are the major implications that you could have written. Then at last you can write that ITER, if it delivers, can open a plethora of opportunities for clean energy through nuclear fusion. That will become your conclusion. Understood? This is how you should have written this question. This question, out of these the four questions that have come in this exam, I would say this one was the least expected or where student faced more difficulty. Other questions were more easier than this. Now, if you see introduction, you need to write about ITER. After that, we drew a timeline to show India's nuclear fusion timeline. Then we wrote about India's contribution. In that, we divided it so that we don't exclusively focus on major component supply, because we will know less here. So, instead we made it very comprehensive and wholesome. Then after this, we wrote about implications for global energy. Then you can conclude it that if it delivers, then it will open up lot of opportunities for nuclear fusion based clean technologies. Understood? This would have been a very good answer, but of course I or anybody have written this not in exam conditions. So, do not worry that you should have written this much. Okay. And people who are seeing this, now if you see a question similar next time, then you have all these points for you. Okay. Let us move to the next question. Yeah. Next question is, how clean technology how can India achieve energy independence through clean technology by 2047? How can biotechnology play a crucial role in this endeavor? Now, see, there are two parts to the question. First, it says that how can India achieve energy independence? Energy independence is what? Basically, you are self-reliant completely on energy. Okay, through clean technology, because we cannot be just self-reliant, we also have to do it in a clean way, because of the impending climate change challenges and all. So, by 2047, this is our target. Now, how can biotechnology play a crucial role in this endeavor? Then we will see what role biotechnology can play in this. So, you can start with a good introduction will be India faces the twin challenges of rising energy demand and facing down fossil fuels. This makes energy independence via clean technology imperative. Okay, this is a good introduction. Why? Because it compares two things. Okay, this is a way of writing introduction. So you first write India faces the twin challenges of there is rising energy demand in India. By 2047 we will require 3x the energy that we require right now, and we have to phase down coal also, because by 2070 we have to achieve net zero emissions. Now in these two, if comparing both these two challenges, what is the solution? Solution is we need to achieve energy independence via clean technology. Correct? So this becomes your introduction. It tells the problem also, okay, and it also connects it with the remaining part of the question. That is, you need to achieve energy independence via clean technology. Now the next part. Next part is about pathway. What should be the pathway? How can India achieve energy independence through clean technology? Next part is this. So let's see the next part, that is the pathway. How India can achieve this. Okay. Now, how India can achieve this? See, first thing that we should do, our pathway using clean technology to reach energy independence is we need to increase our renewable energy capacity. In this you can write example of 500 gigawatt by 2030. This is our target. Target of 500 gigawatt by 2030. Then one major issue with renewables is of energy storage and smart grids. So you can write improve energy storage and develop smart grids. Okay, this is another pathway. Then for example, lithium ion storage units. These storage units are being established in different states in a lot of numbers. Now third thing that you can write is we need to accelerate EV adoption and its infrastructure. Correct? Because electric vehicles will help us reduce the need for fossil fuel. Correct? Now next, in this you can write example of FAME India. Correct? Next is carbon capture and utilization technology and waste to energy plants. This will help us generate, again this will reduce our carbon emissions, and as well as waste to energy will give us energy that is clean. Okay, like biogas and all is also forms of clean energy. Now one more that people may forget is small modular reactors, nuclear energy. Nuclear energy is also a form of clean energy, even though it is not strictly renewable energy, but it is still more or less clean. Now in this you can give example of our target of 100 gigawatt by 2047 through nuclear energy. So all these are the pathway through which we can achieve. You have to write complete thing: clean energy independence through clean technology. This you have to write. Okay, so this becomes your main pathway. Understood? Once you have written the pathway, now what you need to write is the other part. What's the other part? The other part is role of biotechnology. So you write role of biotechnology. Role of biotechnology in this. Now what is the role of biotechnologies? 4 or 5 points you can write. Okay, you can write biogas and biofuel production. Correct. You can give example of ethanol blending oil, or you can give examples of biogas plants that are established in villages. That example you can give. After this, there is wastewater to energy. For this you have microbial fuel cells. These microbial fuel cells can generate electricity using conversion of wastewater to energy by biological resources. Then this people will forget, that is bioplastics and biomaterial. See, understand, these bioplastics and biomaterials also come from fossil fuel sources. Okay, so if you can make them through biological resources, then also you are decreasing the fossil fuel demand. So this also is a way of in which biotech can help. Now, here when you are writing biogas and biofuel production, you can also mention, that is fourth generation biofuel, which is engineered algae. Okay, to make it a bit more technical. Then there is also called something biocarbon capture and utilization technologies. In this, some microalgae are developed that can do carbon sequestration, carbon dioxide sequestration. So all these are role of biotechnologies that you can write. It depends on you how much time do you have. If you have more time, you can distribute this. Biogas production is one point, you can write in villages this. Biofuel production becomes your another point. So you can increase the points from here only. Now, after this, you can just conclude it like clean energy is the need and the only way forward to achieve India's energy independence by 2047. Some simple conclusion is fine here. Now, so what you have written in this, let's see. See, you started with something like this, that India faces twin challenges of this. You introduced clean tech being imperative for energy independence. Then you told about the pathway of energy independence via clean technology. Correct. After this, one specific thing was asked from you, that is role of biotechnology. That is it. You don't need to write anything more. Why not? Because this is a 10 marker question and you will have limited time. So instead of focusing on writing way forward or this and that in 10 markers, if you have enough points with this, and in this you already have 2 parts to the question, so just stick to them. Concluded, that is it. Move forward in life. Okay. Then next, let us do next question. Yeah, this is a expected question. This is in test series of most institutions, and now they will claim that everything comes from our test. Okay. So this is a very generic question. See, how does nanotechnology offer significant advancements in the field of agriculture? How can this technology help to uplift the socio-economic status of farmers? Now understand, there are 2 topics specifically in GS3, that is, one is role of technology in agriculture, correct, and the other is some technologies that are mentioned in the science part, that is nanotechnology, correct. So this lies at the intersection of both of them. In fact, whenever you study science in tech, okay, just remember that this topic is also there, that is role of technology in agriculture. Now because you have this topic, whenever you read some new kind of technology that is coming in the world or that you are reading extensively, always focus that you connect it with agriculture and prepare a short note on it. So it may be AI in agriculture, it may be blockchain and agriculture, it may be in this case nanotechnology and agriculture, correct, robotics and agriculture. All this you should prepare. Every year you will find some of this is asked. They are not asking about the traditional technology that is used in agriculture. They are focusing on the modern or emerging tech only. So you prepare when you are preparing emerging technology, which you anyway have to prepare for prelims also, for mains also. That is also a topic. You specifically prepare for agriculture. Okay. Now, if you have done something like this, this becomes a very simple question that you can write within time or actually save time in it. Okay, because you have already prepared the answer. Okay, some questions are like this are always given in most papers, which you have done extensively. So just write them very fast and save that time if you can. Then yeah, so let's start. How you will start it? You can start with the definition here, it's fine, that nanotechnology is the science of harnessing differentiated properties of materials at nanoscale. Correct? Nanotechnology is the science of harnessing differentiated properties of materials at nanoscale. Correct? So, properties that are only shown at the nanoscale, that you harness in nanotechnology. Now, this can have many uses in different fields. Straight away you can now get to how does nanotechnology offer significant advancement in the field of agriculture. Straight away you can ask, just writing one generic sentence of it has plethora of applications in all fields like agriculture, industry and health, etc. It does not add much. Okay, so you after this you can straight away come to the topic what you have to write. Now, so you can put a heading of advancement offered by nanotech in agriculture, as was asked. Now, what are the advancements offered? Now see, there is a way to write questions like this. One of the ways that you might have heard of is life cycle approach, that we will be using. Okay. Now, if you have done farming or seen farming being done, what is the first thing that is done? The first thing that is done is sowing of seeds. No, before that what you have to do? You have to do soil preparation. Okay, soil preparation, water source, everything you have to arrange. After that only you start sowing seeds and everything. So, first thing that you should do, or in which nanotechnology can help, is timely soil and water management. Through nano sensors. Correct? So, it will check your soil, or if every nutrient is present fine quantity in your soil, if there is some need, if there is enough moisture in the soil, everything it will try to see using nano sensors. This is the first thing, correct? Now, the soil is prepared. Now, once the soil is prepared, what you will do? You will sow the seeds. Now, what you will need next is precision nutrient delivery. Correct? Now, you have sown the seeds. Now, for seeds to germinate and grow into a good, nice, beautiful plant, what it will need? It will need precision nutrient delivery. Now, where does nanotechnology help here? Nanotechnology can help increase yield and decrease wastage. Here you can write example of liquid nano urea and nano DAP. Okay. These are the examples that you can give. This is for precision nutrient delivery. If you know that what nanotechnology can do, what they usually do, they start releasing all these nano based fertilizers or urea or pesticides, they start releasing nutrients very slowly. So plant is able to absorb them much better, correct. If plant absorbs them much better, the wastage is less. So efficiency also increases, uptake also increases, and yield also increases. Okay, but it is asked advantages offered, so we are not going in much detail to write the entire process. If you want, you can draw a diagram on the side. Then see, many people will overtly focus on this liquid nano urea. They have read other parts, they have not read that well. So that makes your answer a bit one dimensional. That is why I have concised it in this much part only. Okay, instead of writing about liquid nano urea and all, because this is just one of the applications of nanotechnology. That's it. That is precision nutrient delivery. We have to make it more comprehensive. Then next, now that you have put nutrients and all, there is need for early diagnostics. There is need for early diagnostics of any disease. Okay, so if your plant is getting any disease, that is early diagnosed. This is done through bio nano sensors. For example, gold nanoparticles can do this. Okay, then after this, so what you started with, first you prepared the soil, then after that you gave nutrients to the soil, then you are doing early diagnostic if some disease is developing in the plant still. Okay, now you are able to diagnose it at a much earlier stage and try to prevent any spoilage. Then even then if some pest or something is caught or catches hold of your plants, then what you should do next is pest and disease management. So if still these plants get some diseases, then you can use nano particles, example, or just write directly silver nanoparticles. What silver nanoparticles does? It straight away goes through the bacteria's gut and tries to break it completely. So silver nanoparticles is used as a germicide or bactericide. So this can be done with respect to pest and disease control. Then now everything you have done, one thing still remains, that is once the crop is grown, you have post harvest methods. In this you can write about nano coatings and packaging. Nano coatings and packaging will do what? It can do two things. It can reduce spoilage, correct, as well as increase shelf life. These are the two things it can do. So this becomes all the advantages offered by nanotechnology in agriculture. We have substantiated each of the points with examples. You should also do this. Instead of writing very big sentences, like you can also write it like this, that nanotechnology improves delivery of nutrients as well as their uptake and efficiency, but it takes a lot of space and it does not add much to your answer. Instead, if you directly write, this just does precision nutrient delivery, this is what it does, and now you have given an example also. With this you get increased yield and decreased wastage, and you have given example. Now in very short you have covered much more important things. So this is how you need to write. Okay. Then you come to, so this is whole life cycle that we have completed of the plant. Now we come to the next part of the question, which is socio-economic benefits for the farmer. Socio-economic benefits for the farmer. Now some students faced issues in writing this, because what they had learned is use of nanotech in agriculture they had learned, but now socio-economic benefits for farmers, they were thinking that what we should write in. The thing is simple, if you know the benefits, that is in agriculture, those benefits will be obtained or will be enjoyed by the farmers also. Just the structuring of your sentences will change, that is it. Now, so first thing is higher yield and lower input cost, correct. If the efficiency is more, then it will have lower input cost and yield will be much higher because the uptake is much better. Then here you can give example of nano urea. Then next is, I am just rephrasing those only. So next is risk mitigation via early detection, correct. Early detection we wrote above, now I have just reframed it, risk mitigation via early detection, correct. That is again helpful to farmer, before spoilage only he will get to know. Then next is longer shelf life. Now if something has a longer shelf life, what will happen to farmer? Less distress sales, correct. If you go in the evening time to a farm, to someone who is selling vegetable, they tend to sell it at very cheap prices. Sometimes farmers also have to do that to their entire crop, because their season is passing or their crops will get destroyed or spoiled in a few days. So they have to sell it at very low prices. Now with nano coatings and all those technologies in post harvest, what we can do? We can have a longer shelf life. So there won't be distress sale by the farmers. Then next is better quality yield you will see, correct, with all those precision farming things. Then one thing that you can write is long term better soil health also farmers will get. This will, you can use term like decrease artificial desertification, correct. This is a issue that our farmers are facing, especially in regions of Maharashtra and Rajasthan. What they are facing, that artificially it is turning into a barren land because of extra use of nutrients and all. Now then one more point is, that is a unique point, is insurance access. Now what they can get through their sensor data, they can get better insurance, because insurance company, why they don't want to give insurance to farmers or loan to farmers, because they don't know if the crop will grow fine and he will be able to repay the loan. Now with all those sensor data that is available to the farmers regularly, if it is available and he presents this data, then they will be more sure that this crop is most probably going to grow well. So this also you can write. Then you can also add generic points like diversification of crops, more value addition, those also you can write, value addition and diversification. So many points you can write like this. This becomes what? This is socio-economic benefits for the farmers. Understood? Then now here for the first time I would suggest that you add another part, because this is a 15 marker question. Now you should add another part to it, that is See, it had only 2 parts. This is a 15 marker question, but there are only 2 parts. First was that what are the uses or use cases of nanotechnology in agriculture, potential advancements. The second was benefits for socio-economic condition of farmers. Now, what you can now add is a third part, very short part, just for the checker to see that you have given something extra, because there are only 2 parts and this is a 15 marker. So, write some challenges to it, like very short, not much. For example, high cost is a challenge, then low awareness and adoption is a challenge. Then next, quality and regulation is a issue, and last that you should always write in all kinds of nanotechnology answer is ecological toxicity of nano materials. See, if you might have heard about microbeads. Now, microbeads, they are still much bigger than nanoparticles, are a big issue now. Now, we may discover later that these nanoparticles are also getting accumulated in different plants, animals or humans, and it is causing a lot of difficulties. Now, disposal of these nanomaterials also become very difficult, correct, because they are very small in size. So, ecological toxicity is a major issue with respect to nanotechnology application. So, these are the 4 challenges, that's it, that much you need to write. You can conclude it with, despite these challenges, nanotechnology deployed suitably can greatly help India's agriculture. Simple. Despite challenges, nanotechnology is can still help India's agriculture to grow, or something like this. Basic introduction you can give, conclusion you can give. So, this is what I would expect people to write in this answer. So, you start with nanotechnology's definition, then you write advantages offered by nanotechnology in agriculture, then socio-economic benefits for the farmers, after that some challenges, and then despite challenges nanotechnology is very nice. That will be your conclusion. Understood? Okay. Then let us move to the last question. Okay. Last question is, this was again a expected question because a lot of it was in news, that is with respect to semiconductor mission. Now, India aims to become a semiconductor manufacturing hub. What are the challenges faced by the semiconductor industry in India? Mention the salient features of the Indian semiconductor mission. Okay, semiconductors were a lot in news. So, this was also a expected question. Okay. Now, how you can start this? See, first thing you need to address this. India aims to become semiconductor manufacturing hub. This is what India aims to become. Now, why it aims to become? Something you just mention in one line. Okay. So, introduction can be global semiconductor market is worth $600 billion. India currently a heavy importer. This you can write in bracket, the current scenario of India. India, then continue the sentence, India aims to take a significant chunk of this sector. Correct? So, in first line you explain that why this semiconductor market is worth upwards of $600 billion. Then you explain that India is currently a heavy importer and our aim is to become a major hub or to acquire a significant chunk of this market. So, in this introduction you have already introduced 3 things together. Okay, now let's get to the main question. What are the challenges faced by semiconductor industry in India? Now, so let's write the challenges that the industry is facing. So what will be the challenges? See, first major challenge is high tech and capital requirement. The technology and capital requirement is very high. Now, for example, this fab labs or fabrication labs, they take more than or approximately $10 billion to start. This much is the cost of major, if you want to develop a major fabrication lab for semiconductors, it costs you around $10 billion, correct? Now, so this is a huge issue. Then second is the supply chain is very complex. Okay, like India has to import most parts. For example, India imports wafers, okay, equipments, everything we tend to import. So this also is a very major issue. Now, complex supply chain, why? Because there is also a lot of international tussle that is going on with respect to supply chain of semiconductor materials. Then next, is human resource. So there is a major lack of human resources also, or an issue of out migration to USA, Korea, Japan. So all those people who are trained in India for these technologies like VLSI and all, which are useful in semiconductor production, they tend to out migrate out of country. So human resources is also an issue. Then there is global competition, because this is being touted as the major playground for international politics going forward. So there is a lot of global competition. Then there is need for constant or reliable energy and water sources. Now this also is a problem in most cities in India, that is providing high volume of water and energy consistently. That is also a challenge that we face. Okay, so these are the major challenges that we see. Now, second part is India's semiconductor mission, which will try to do what? Which will try to provide solutions of all these challenges. So this is already a comprehensive question. Challenges we have written. Now we will see Indian semiconductor mission, which will try to provide solutions for this. Now let's see. Indian semiconductor mission. Now see, if you remember everything about India's semiconductor mission, then it's fine. Otherwise, you can always write some generic points. Those also we'll try to introduce. Now see, first is the most important, that is financial incentives that is government provided. It is 50% of project cost. So 50% of project cost in this, in fabrication labs. So for developing or making fabrication labs and equipments, everything, what the government is doing, government is giving 50% of project cost itself. Then next is skill development and research. For this, government is making training institutions as well as center of excellences in IITs, IISCs, etc. Okay. This is for skill development and research, because we had a problem of human resource also, so that gets tackled. Then next problem was what? Next problem was global competition. So what's the solution? Global collaboration with like-minded countries. For example, we are trying to get tie-ups with Japan and USA. Okay, so this is again a solution that we have planned in our Indian semiconductor mission. Then what more? Then you have ecosystem building. Correct? We had an issue that we didn't have sufficient ecosystem, that is of domestic suppliers and equipments, etc. Everything we were importing. So that also government is trying to promote. Then what next? Then government is providing design linked incentives to industries. This is to promote industries to invest heavily in semiconductors. Okay, so these are the major points that you can see with respect to Indian semiconductor mission. Okay, you can always see all these missions and all. First thing that you need to understand is what they will usually involve. See, I will tell you something. In science and tech, what you can use this. You can use this acronym. Okay, through this you will be able to write challenges as well as what any science and tech mission will include. So first is resources. So some financial, some land, some capital resources government or will be providing, as well as this will be a challenge, high cost and all that. Second is some kind of international issue, like we saw that there is competition with respect to semiconductor. In solution is also some kind of international collaborations, we'll form some organizations or groups or something like that. So that becomes your challenge as well as solution. Next is issues with respect to supplies or suppliers. Okay, so you will see most of it we are importing or there is import dependencies. This we are importing, that we are importing. There are not enough suppliers. There is not enough supply in nuclear or anything. So this supplies become a issue. As well as solution is again you need to have domestic suppliers, indigenous manufacturers, like that. Then H becomes your human resource development or human resource availability. Correct? That is skilled human resources lacking. I becomes your industry linkage. So whatever issue your industries are facing, why they are not setting up plants like this, what issues they are facing. For example, in this they were facing infrastructure based issues, that is not regular supply of electricity and water, and certain systems in place are not there. So that will be a issue, and the solution will be industry linkage or creating an ecosystem that is much better for the development of this particular industry. This Rishi will help you write most of the challenges as well as solution with respect to science and tech questions. Most missions also revolve around this. Okay. After this, you can end it. In conclusion, what you can write is semiconductors lies at the heart of modern electronics and industry 4.0. India must focus on it to achieve 5 trillion economy. Okay, something like this you can write. correct. This you should mention that semiconductor is at the heart of industry 4.0 or modern electronics, correct. That is why it becomes so important for us, and that is why India must invest on it heavily. So, if we want to achieve 5 trillion economy or economic growth at that rate, we will need to develop our semiconductor industry. Okay. Now, let us see what we have written in this answer. We started with global semiconductor market is worth that much, India is majorly an importer, India wants to take a significant chunk. Then we wrote about all the challenges that our semiconductor industry faces. Then we saw what India's semiconductor mission entails, and then we concluded it that semiconductor is very important for industry 4.0 or emerging technology. So, we must focus on it a lot. That becomes your answer. Okay. So, these were your 4 questions as well as your answers. Hope you like this session. Thank you.